Hi, I'm Melissa at Keysight Technologies, and I'm so excited to introduce the entire family of the Infiniium UXR-Series Oscilloscopes. You may have heard of our 110 GHz oscilloscope, and now that technology has been leveraged and optimized all the way down to 13 GHz of bandwidth. You can develop what has never been developed before and achieve a new level of accuracy in your designs. These oscilloscopes offer the world's best signal integrity with up to 6.8 effective number of bits. This is particularly important as you start to design the next generation of digital technologies. At the speeds we're transferring data these days, millivolts of noise can make the difference between passing or failing compliance. There's nothing more frustrating than having schedule delays because you couldn't validate your designs due to measurement system noise. The UXR only introduces a record low of 210 microvolts of noise at 10 millivolts per division on the 13 GHz model, and as you'll hear later on in the video, the noise specs and signal integrity are equally impressive at 110 GHz. You also no longer have to worry about the notorious issue of bandwidth dropping when you need to run multiple channels at once. All 4 integrated channels run at full bandwidth all the time, no matter how many channels you have turned on. This is especially important if you're working on coherent optical designs and need to validate your optical receivers. Daisy-chaining test equipment together to get the right number of channels is not only cost prohibitive, but it introduces complexity in test setup and adds extra jitter between channels. There's less than 35 femtoseconds of interchannel jitter, keeping multi-channel measurements clean and accurate. One of the best functions of the UXR series is that these oscilloscopes can grow with you over time as technology speeds continue to increase and your designs advance. All 21 models are fully upgradable. 13 GHz models can be upgraded all the way to 110 GHz, and 2-channel models can be upgraded to 4 channels. Buy what you need now with the flexibility to upgrade in the future. This has been a major undertaking of not just our R&D team, but several groups here at Keysight, and we are excited to see how you use this technology to revolutionize the world.
The new world that symbolizes man's dreams, hopes, and aspirations. We find inspiration for new ideas and the grounds for renewed faith in the future.
Today we have some keynote speakers to discuss several topics, including the technology we created in order to make a 4-channel 110 GHz oscilloscope a reality, and how these oscilloscopes will change the game for high-speed digital, RF, and other industries. And stick around to the end because after our keynote speakers, we'll be showing you some measurements on the UXR and telling you where you can get a third-party review. So without further ado, we'll transition over to Jay Alexander, coming to us from Santa Rosa.
I'm Jay Alexander. I'm the Chief Technology Officer at Keysight Technologies. The new UXR series of oscilloscopes is really a flagship example of Keysight's commitment to leadership in the test and measurement markets. And when we consider the specifications on these products, we can see why. From the 256 gigasamples per second sample rates, the 10-bit A to D converter, 2 gigapoints of memory, sub-millivolt levels of noise, and 35 femtoseconds of interchannel jitter. Every one of those market-leading specifications and capabilities requires one or more new technology blocks, both hardware and associated software. Those technology blocks are designed, developed, and in some cases manufactured at Keysight. They represent Keysight's proprietary capabilities and everything that we're able to bring to bear to meeting the most demanding customer needs. We're doing it with oscilloscopes, we're doing it with network analyzers, signal analyzers, signal generators, arbitrary waveform generators, and all of the other key categories in our industry. We do it so we can help our customers deliver their innovations and their breakthroughs and help lead the ecosystems. We're very honored to play this role, and again, the UXR series is just a great example of Keysight's commitment to these markets.
When we look at the big drivers in our end markets today, the first big driver is data. Data usage in mobile networks are at a record high. And the biggest challenge for customers in today's world is to make that data usage more efficient at a higher data rate. And there is complete communication systems redesign all the way from chipsets, devices, to data centers that's occurring and will continue to occur over the next 10 years. The next big driver is around the autonomous car revolution that's happening. The autonomous car revolution is creating an electronification of a car at unprecedented levels that makes a car look more like a smartphone than it looks like a conventional car that we're used to today. The aerospace and defense markets, the threat scenarios that our security agencies have to deal with today are very different, requiring higher and higher fidelity radar signals that can sample wider bandwidths in order to capture the threat environments of the future. All these have profound implications to the design and test industry. What was normal performance in the past is not sufficient in order to characterize these big drivers, which is why Keysight is very proud to introduce a communications platform, the UXR, that is positioned to solve problems today for our customers, but has extensibility and applicability for some of the problems that will come in over the next decade. And the UXR, with its industry-leading wide bandwidth technology, best fidelity noise performance, and multi-channel coherent capabilities, enable our customers to start with solving the problems of 400G or terabit Ethernet or PCI Gen 5 today, but then extend it into solving the multiple industry problems that will emerge over the next 10 years. And we're very proud at Keysight to be creating, with these investments we have made in R&D, to be creating this platform to ensure our customer success, true to our mission statement, to accelerate innovation, to connect and secure the world.
In Colorado Springs with me is Dave Cipriani, Vice President and General Manager for Keysight's Digital and Photonics Center of Excellence. Dave, I know you've been closely connected with this project since it began. Can you share with our audience the goal we had in mind when we set out to take on this project and what we've managed to create?
Sure, Melissa. When Keysight first began discussing our next generation oscilloscope, market drivers were demanding higher bandwidth, extremely accurate measurements in a multi-channel system, terabit optical data communications, next generation digital bus standards, high-speed I/O in ASICs and FPGAs, new wireless standards. All of these applications required improved performance. Keysight determined that these next generation measurements should not be made by leveraging up performance points with existing technologies through techniques like frequency interleaving. The trade-offs with measurement quality are too impactful. Our objective was to deliver a system with low noise, low jitter, and a high number of effective bits, or ENOB, at 110 gigahertz. To achieve this, a multifaceted technology development program was initiated across the company. The starting point was our internal indium phosphide IC process. Keysight developed a next-generation process with improved speed and noise performance that supports direct signal capture at 110 gigahertz. This process was used to develop our front-end signal conditioning ICs, including a very low noise 110 gigahertz input amplifier and a 256 gigasample per second 110 gigahertz sampler. As the market required flexible input ranges, we also developed a 110 gigahertz electromechanical attenuator. The IC process packaging, and manufacturing processes for the front-end module and the attenuator are all Keysight proprietary. Behind this advanced front end is our proprietary 10-bit A to D. Each acquisition board samples at 256 gigasamples per second, and there are 4 full bandwidth channels per system. That's over 10 terabits of data captured per second. Put another way, the UXR makes 34 measurements in the time it takes light to travel 1 centimeter. To process all of this data, our proprietary 100 million gate 28 nanometer CMOS ASIC was developed. This data processor performs several functions, including hardware acceleration of waveform display and measurements, along with correction filters and providing memory management. As a result, the UXR displays over 100,000 waveforms per second, speeding up debug of any digital system. And 1 million real-time eye measurements are made per second, accelerating the debug and analysis of serial buses and high-speed I/O channels. The overall system design focused on minimizing noise. The UXR series has 40% lower noise density than Keysight's current generation of products. A 110 gigahertz of measurement at a sensitivity setting of 10 millivolts per division only has 750 microvolts of RMS noise. And again, that's at 110 gigahertz of bandwidth. The clock generation circuitry, combined with the low noise system, enables an unprecedented, very low 20 femtoseconds of jitter on a single channel. And the reason that's the spec is no instruments can measure any lower. Interchannel jitter is 35 femtoseconds. The low noise and jitter mean larger, more accurate measured eyes. And the extremely low interchannel jitter is important in coherent applications. But our technological innovations did not stop there. Bandwidths over 70 gigahertz require 1 millimeter connectors, which are known to be easily damaged and are expensive. To overcome this, Keysight designed proprietary ruggedized 1 millimeter connectors. Also knowing that customers who purchase a UXR system demand the most accurate measurements, a proprietary calibrator supporting on-site measurement calibration was designed. Combining all of this capability yields a system that can make a 110 gigahertz measurement with an ENOP of 5 effective bits. Keysight started out with the goal to develop a next-generation oscilloscope with unprecedented performance. Not only did we accomplish that, we've invented the next-generation communications platform.
We've done a lot of talking today about the oscilloscope, so now let's go see it in action. This is Joe Haber, the UXR Product Manager. Joe's going to demonstrate the UXR's calibration module so you can see one of the fastest signals ever measured on a real-time oscilloscope. And he's also going to take some baseline noise measurements so we can look at the signal integrity of these oscilloscopes.
Thanks, Melissa, and thanks all of you for tuning in today. You've heard some of the amazing new innovations that have gone into making the UXR the most powerful and accurate high-performance oscilloscope in the world. I'm going to demonstrate the UXR's performance and noise floor, but first let me explain what I'm using to create an edge fast enough to demonstrate the UXR's capabilities. What I have in my hand here is what we call a calibration module. It consists of a remote head that houses an indium phosphide powered step generator capable of creating a very clean, fast edge, and an autoprobe pod using Keysight's new Autoprobe 3 technology. This is the same hardware used at the factory to calibrate the UXR, but we've made it available as an option on the UXR. The module is calibrated to hold NIST traceable calibration factors associated with the remote head's various output signals, and it stores them in the pod. This enables the UXR to self-calibrate its channels based on the various received input signals and the data that's stored inside the calibration pod. The end result is not only the ability to demonstrate the scope's bandwidth capabilities, but also the ability to do a full factory quality frame calibration on site and under the scope's actual environmental conditions. Here I have the calibration module generating a fast edge into channel 2. I have the UXR's bandwidth set to 113 gigahertz. Let me turn on channel 2 so we can see the signal coming in from the calibration module, and I'll zoom in so you can get a better look. Okay, so here we can see the fast edge coming into the UXR from the calibration module. I'm going to easily grab a falling edge measurement and drop it onto the signal. Down here, we actually see that the average edge being measured is 3.42 picoseconds. That's truly amazing performance and is something that couldn't be done before the UXR. But speed means nothing if your scope doesn't have the signal integrity and effective number of bits necessary to provide meaningful measurements. Now, how do we look at the noise floor of a scope? An easy way is to measure without anything connected to the oscilloscope's channel. So what I'm going to do is I'm going to turn off channel 2 and I'm going to turn on channel 1. We're now looking at the noise floor of the scope because I have nothing connected to channel 1. What I'm going to do here is I'm going to zoom in and I'm going to come into 50 millivolts per division. This is a common vertical division that's used on data sheets around the world for oscilloscopes, and it's a good place to show you the performance of the scope's noise floor. So what I'm going to do here again is I'm going to now switch to a vertical measurement, and I'm going to drop an RMS measurement onto the signal. And now down here we actually see that the average noise floor is 2.64 millivolts. Okay, now that is actually best in industry noise performance and is better than some scopes with half the bandwidth. But what if you don't need 110 gigahertz of bandwidth? Well, let me set up a brick wall filter to 50 gigahertz. All right, so we're going to go to 50 gigahertz. And now let's take a look at the noise floor of 50 gigahertz. All right, here we are, 1.79, 1.8 millivolts. Okay, again, truly amazing performance. Now you may be wondering, what about even lower bandwidths and higher sensitivities? Okay, well let's take it down, all the way down to 1 gigahertz. And let's go down to 5 millivolts per division. What do we see here? 79 microvolts of noise. Okay, truly amazing performance. So what does all this really mean? Well, it means the UXR has the best signal integrity in the industry and enables you to see signals like they're actually being experienced by your designs. For instance, you will now see 40% more open eyes and have the ability to use equalization to open closed eyes that previously couldn't be opened before. This additional margin could be critical to getting to market fast and first, ensuring compatibility and even avoiding unnecessary redesigns because your oscilloscope noise was obscuring your actual signal performance. Now, we all know you don't get extra credit for using more bandwidth than you need. That's why the UXR offers models from 13 gigahertz all the way to 110 gigahertz. The performance and breadth of UXR series really opens up new dimensions, enabling you to do what has never been done before.
Hello, my name is Brig Asay and I'm the Director of Strategic Planning for Keysight's high-speed digital solutions. I'm very proud to be part of Keysight to see such an innovative product come to market. The UXR is the first scope to bring 10 bits to market at greater than 8 gigahertz. It brings an industry-leading noise floor and jitter measurement floor to market. This is absolutely critical to bringing technologies such as PCI Express and C6 to market. Today's high-speed digital serial buses are pushing the limits of speed and thus reducing critical specifications such as eye height and eye width. PCI Express, after you apply all the channel losses, has an eye specification of less than 20 millivolts. That specification doesn't build extra tolerances for your design for things such as oscilloscope noise. When margins are tight, you want to see what your signal truly is, not just your signal plus extra scope noise. The UXR will allow you to see your signal closer to reality than any real-time scope in the market today. So now let's go back to the PCI Express example. Before the UXR, eye heights would measure at best 8 millivolts. After taking the exact same measurement on the UXR, the eye height showed an incredible 14 millivolts. This is absolutely huge. This means greater than 40% higher margins than you've ever seen before. Now, high-speed digital isn't the only technology that'll benefit from the UXR. In the communications world, everyone is talking about 5G. Key bandwidths for 5G are found at 28 and 39 gigahertz. The UXR, with its 110 gigahertz of bandwidth, allows you to directly digitize all 28 and 39 gigahertz. Its noise floor of 164 dBm per hertz and its signal to noise and distortion ratio of greater than 40 allows you to see more of that 39 gigahertz than you've ever seen before. Even better, there is much discussion of 5G moving above 39 gigahertz. The UXR, with its 110 gigahertz of bandwidth and really low noise to that full bandwidth, ensures you are absolutely future-proof for any further bandwidth extensions of that 5G network. The technologies don't stop there. Consider the 802.11ay specification. This is a wireless LAN specification and is designed to run at greater than 60 gigahertz with multiple in, multiple out technology. The key test and measurement metric for an AY signal is EVM. Recently, the UXR measured an incredible EVM of less than 1.5%. This has never, ever been done before. In addition to an amazing EVM, the UXR features 4 channels of bandwidth and an extremely flat frequency response, meaning that the EVM measurement is consistent across multiple measurements and is absolutely ideal for MIMO. The UXR is good for high-speed digital, 5G, wireless LAN, but there's even more. The scope is ideal for your coherent measurements as well. One of the key specifications for coherent measurements is ENOB. This is the effective number of bits of a scope. Coherent will use bandwidths of 70 to 110 gigahertz, which the UXR has. It also has 4 channels to properly look at IQ. The UXR has these 4 channel bandwidths, which are calibrated to have an inner channel jitter of less than 35 femtoseconds. Yes, I said 35 femtoseconds. Now back to ENOB. Previously at 70 gigahertz, the best ENOB measurement was around 4. The UXR absolutely crushes this measurement with an effective number of bit measurement of greater than 5.5. Nearly 1.5 effective bits better than anything that had ever been measured before. This makes it very easy to see true 64 QAM signals and your coherent measurements. Now, we haven't even began to talk about satellite communications, automotive radar, high energy physics, quantum computing, and many other technologies that the UXR is the perfect instrument to make never-before-seen measurements on. It is not just a high-speed digital instrument, it is an RF scope, it is an optical modulation analyzer, and it's time for you to do what has never been done before.
Hi, I'm Stephanie Rubalcava. I'm an R&D Application Development Engineer. Specifically, I develop PAM4 solutions. Noise can affect measurements on PAM4 signals. With noise as low as 210 microvolts RMS, we can make accurate eye measurements and truly know that our designs meet and exceed the specifications. The PAM4 signal setup enables you to set measurement definitions that represent your receiver sampling time and how the receiver slices the data. You can set receiver sample time based on center of the eye, per eye level, and you can also define that center location by maximum eye width and eye height. Let's set up the eye measurements using the PAM4 wizard. Set up data rate. The clock recovery, I will set it up for first order PLL at 4 megahertz, which is the IEEE specification for clock recovery. It will automatically set the memory depth. It will automatically calculate the thresholds for each eye based on the measurement definition set previously. You can select several common measurements such as noise, TIE, eye height and eye width measurements, and rise-fall time for each transition. Now that we have PAM4 eyes, we know that we have accurate results. The UXR also has 2 compliance apps, an IEEE application that covers the BS and CD specifications, and the CEI application that covers the 56 gig VSR, MR, and LR specs. Now that we've made some basic eye measurements, we can dive deeper into the pulse response, signal-to-noise distortion ratio, and SNR-ISI. Again, the noise is a key component of these measurements, and we are able to make them with such low noise from the scope that we can see the true results. I'm going to go ahead and jump to a report that I ran earlier. This shows the pulse response, the input and pulse-corrected waveform, as well as the error. The UXR is the perfect tool for design verification and margin analysis to the specification.
So today, we've shown you the calibration module and the incredible speeds the 110 gigahertz oscilloscope can measure, plus some live baseline noise measurements. With models ranging from 13 gigahertz to 110 gigahertz, there's obviously a lot more that we could do with these oscilloscopes that we didn't have time to show you today. But if you're interested in more information, you can check out the UXR web pages at www.keysight.com/find/UXR. And even more exciting, check out the signal path. He's reviewed the UXR and posted that review on his YouTube channel. He's an amazing engineer who's torn down a lot of oscilloscopes, So go check out what he has to say about the UXR. In the comments, we'd love to hear what you'd be able to design with the UXR-Series oscilloscopes. And thank you so much for joining us today.
A new world that symbolizes man's dreams, prophecies, hopes, and aspirations. We find inspiration for new ideas and the grounds for renewed faith in the future.